The topic is green technology in wastewater treatment technologies. Integration of membrane bioreactor with various wastewater treatment systems. First, background and key issues. As the population grows worldwide, there are problems with severe shortage of the water. Also, existing conventional wastewater treatment plants are overloaded and there will be no space available for expansion of existing treatment plants. In view of this, MBR has some advantages. MBR needs small space and less sludge production and higher separation efficiency and highly improved effluent quality. So recently, membrane market is growing faster and become large market. In spite of this, conventional MBR has several limitations in the treatment of high-strength industrial wastewater, and there is a need for high water quality. Objective of the study is a review on current state of research for the integrated MBR system with other technologies for wastewater treatment. There are several types of representative integrated MBR. First one is advanced oxidation process combined with MBR, and electrocoagulation process combined with MBR, and osmosis MBR, membrane distillation bioreactor, biofilm membrane bioreactor, and biointeracted membrane bioreactor, and granular MBR, and other integrated MBR for environmental conservation. First, I will talk about advanced oxidation process combined with MBR. This process is like ozonation combined with MBR. This is the UV and this is the MBR. It is useful which containing small amount of biodegradable organics and a large amount of recrucitant compound. Also, it can remove synthetic wastewater contained nalidixic acid, while MBR alone is not efficient in removing this matter. And the integrated oxidation process completely decolorize the effluent and further enhance the removal of COD. There are AOP pre-treatment with NF membrane. It can improve permeate flux. Next is electrocoagulation combined with MBR. The metal ions are generated at the anode, while hydrogen gas is generated at the cathode. The released hydrogen gas will assist in floating the flocculate particles to the surface. In here, electrocoagulation membrane show the best performance in fouling reduction, removal of COD and metals in tannery wastewater. Especially, they have 90% efficiency in removal of chrome, copper, and zinc. It can used for pharmaceutical wastewater and textile wastewater. And then I will talk about osmosis combined MBR. It is called OMBR. Osmosis MBR has advantages such as low energy consumption and good water quality production. There are two types of osmosis MBR. First is reverse osmosis combined with MBR. Since it is operating at a very low hydraulic pressure, so it has a low fouling tendency. When reverse osmosis process is treated with a UF permit, it can successfully remove 92% of total dissolved solid. Other one is the forward osmosis combined with MBR. It also has low fouling tendency, and its removal of the trace of organic contaminants is about 80%. When forward osmosis system meets hollow fiber MBR, it was used for treatment of high-strength saline phenolic wastewater. And when forward osmosis meets anaerobic MBR, it improves the removal of nitrogen and phosphorus. Third one is membrane distillation bioreactor. It is also called MDBR. Membrane distillation bioreactor combines a thermobioprocess with the membrane distillation process. This process transports water vapor through the pore of hydrophobic membrane to permit resolver. Membrane is able to achieve high organic removal efficiency, and the TROC are highly removed above 95% by the system. It has low vulnerability to membrane fouling and low equipment cost, so it is very economical. MDBR is potentially applied in areas where hot wastewater and waste heat are produced in the industry. Next is the biofilm membrane bioreactor. It is called BFMBR. BFMBR is the addition of carriers inside the MBR that reduce the concentration of suspended solid and lead to mitigation of membrane biofouling. It has a resistance to toxic substance. BFMBR showed a better removal in ammonia and TN. This is biointeracted membrane bioreactor, and it is called PEMBR. PEMBR is similar with BFMBR, but little different. Carriers in the PEMBR is developed by immobilizing the cells using entrapment method in here. PEMBR has best performance in terms of both removal efficiency of panel and membrane biofouling, which are 4 times slower than the conventional MBR. It also shows better performance in removal of COD and ammonium nitrogen and longer HRT and continuous aeration. Next is granular ambient. In this process, simultaneous nitrification and denitrification could be achieved inside the granules because of its spherical compact structure. The membrane fouling in this system is reduced significantly by granular sludge. This system also has a great removal of COD, ammonium nitrogen, and total phosphorus. This table summarizes the advantages and disadvantages of the integrated ambient described previously. I will explain other integrated ambient for environmental conservation. First, I will explain the integrated ambient that can produce biofuels. The production of biogas depends on the activity of methanogen. Methanogen has a slow growth rate and easier to wash out from conventional anaerobic treatment systems. For biofuel production, representatively, there is integrated anaerobic fluidized bed membrane bioreactor combined with granular activated carbon. And it was developed to treat domestic wastewater with energy recovery. Integration of heat pump and FO in mesophilic ambient process would be a promising way to net energy recovery. This table below shows the types of ambient and membrane yield generated in each ambient. Second, I will explain integrated ambient that can produce electricity. MFC can convert the chemical energy in organic matters into electrical energy by the catalytic reactions of microorganisms. MFC is generally composed of two chambers, as shown in pictures on left side. The anode chamber, the oxidation of organic compounds takes place under anaerobic conditions, and cathode chambers, the oxygen or ferric cyanide is reduced under aerobic conditions. And the MFC alone leads to low efficiency treatment. On the right side of the slide, there is a table that explains type of cathode, anode, membrane, and power density generated in each MFC ambient system. Last, I will explain about nutrient and metal recovery in integrated ambient. First, ambient ion exchange hybrid system can recover phosphorus and nitrogen from ambient effluent. Second, extractive membrane bioreactor sulfate reducing bacteria is example of metal recovery. And this is the conclusion. Integrated ambient shows better efficiency in treating wastewater than using one ambient. Second, integrated ambient could produce biofuel, electricity, and nutrient metal recovery. And for future trend of integrated ambient technology, researchers need to do more research to reduce fouling rate and energy consumption in integrated ambient. Finally, critics and topic of future studies. I think it will be better if the paper mentions in more details the difference between using one MBR and using an integrated MBR and the need for an integrated MBR. Further research is needed on integrated MBR that is more economical, consumes less energy, and reduces biofouling. Thank you.